This video is on how to do optimization of a DOE model in Quantum Excel. This video is part of a series, and the link to that series is in the description. Before you're ready to do optimization, you should have a fully reduced model. In this case, I have a fully reduced model for the red and blue distance that the catapult shoots as a function of the inputs, which are firing angle and cup rotation angle. To start the optimizer, first we click on QXL DOE and then Optimize. When I click on Optimize, Quantum Excel will ask me the low and high values for the factors. This is the bounds in which the optimization can search for an optimal firing angle and cup rotation angle, which are the inputs to this model. For example, currently the settings are the firing angle can be anywhere between 110 and 130, and so the optimizer will only return values inside of that range. The default range is the range of the DOE, but you're welcome to edit it to include extrapolation. When I click on Next, now we have to define the optimization goal. Because my goal is to optimize the catapult web page gives me a target. So for example, it's telling me that the target for the red ball is to go 650 units. So that is going to be my target for my first optimization, is for the red ball to go 650. To set the optimization goal, click here where it says set the target and either change it to maximize, minimize, hit a target, and then later we'll talk about the minimize DPM for all outputs. In this case, because I want it to go 650, I click on set the target of the red distance and I enter 650. When I'm ready, I then click optimize, and Quantum Excel will give me the firing angle and cup rotation angle that will go 650 units for the red ball. So in this case, the firing angle is 118 and the cup rotation angle is 8. If I click at the bottom where it says save to worksheet, then Quantum Excel will copy those optimized settings for firing angle 118 and cup rotation angle 8 to the set point column. And as you can see now, the red distance is predicted to go 650. To validate that, I would go back to the catapult and I would set the firing angle to 118 and cup rotation 8. I'm setting the firing angle to 118 and I'm setting the cup rotation angle to 8. I then pull the catapult arm back and I shoot. What we'll see is that the red ball landed very, very close to 650, which was my target. However, the blue ball did not land anywhere near its target. The reason the blue ball is not close to its target of 600 is that when I was specifying the optimization, I did not include the blue ball in the optimization. That's quite easy to fix. So I will go back to my model and we will optimize for both balls simultaneously. I click on QXL DOE and then click Optimize. And again, I'm going to use the full range of firing angle and cup rotation angle. And now, instead of me doing this in the optimization goal, I'm going to add a constraint. I click on the button constraint. I'm going to click here where it says red distance y hat, and then I choose blue distance y hat. So that's the mean for how far the blue ball goes. Must be, and the easiest way to do this is to say between, and then I want to pick a very small range around my target, which is 600. So in this particular case, I'll put in 599.9, and the upper range is 600.1. Now, there's nothing magic about those numbers. I could have put in 599.9 to 600. I could have put in 599.999 to 600, but there needs to be a small range there for the constraint. When I click on Optimize, Quantum Excel will tell me that the optimal firing angle is 113 and the optimal cup rotation angle is 27. Again, if I click Save to Worksheet, now you can see that the set points of firing angle and cup rotation angle are resulting in the red ball going 650 and the blue ball going 600. If I then validate those in the catapult, I'll go back and put in 113 and 27. So click Fire again, change this to 113, and then change this to 27. Now when I shoot the catapult, we can see that the red ball does indeed go very close to 650, and the blue ball goes very close to 600. There is more than one way to accomplish this. The other way I could do this is I can actually optimize on the other metrics, such as the CPK and the defects per million. So for example, a very easy way to optimize is to click Optimize, again choose the default lows and highs, and instead of having constraint, I'll remove the constraint. I will make the objective to minimize the defects per million for all outputs. Because I've defined the lower spec and upper spec limit for both outputs, when I choose minimize DPM for all outputs, it will try to find the input factors that optimize the predicted mean and standard deviation for both the red and blue ball so that the combined defects per million for both of them is as small as possible. So because it's for all outputs, it does multiple response optimization with a single goal. When I click on Optimize, Quantum Excel gives me a very similar answer. It says that the firing angle is 113.7, we'll round that to 114, and that the cup rotation angle is 29. Again, I will save that to the worksheet, and then I will go back and type in 114 and 29. So fire again. I'll go back to the catapult and set the firing angle to 114 and the cup rotation angle to 29, and now I'll shoot the catapult. And we can see once again that the red ball goes very close to my target of 650 and my blue ball goes very close to my target of 600. That is how you optimize a model in Quantum Excel.